So hello everyone. Now we are back with that second part of the video. Now the point is, I have already uploaded one video on the actual theoretical perspective on how to actually do this water jug problem. Now, in this particular video, I shall be going through the BFS implementation of the assignment that has been provided to me. I don't know how I will be able to make that video within like the next 20 minutes because I have class from 5, but whatever. Now the point is that let's get started directly. Okay, don't waste time. So this is the BFS implementation. This is written in C. I know it has been told to write it in Python, but I think that C programming will get you a more deeper idea on how the program actually works. Now, this is the style I basically like with, where you have a very small main program with a menu function, because that menu function will be governing all of your choices. Now, the point is that you have a choice, and this is the choices that these are the choices that you actually have available. Now yeah, I was going to implement this because okay, so understand that there may be very stupid users, right? So what they do, they basically input more stuff than you might be required. Like I told you to input 1 2 3 4, and they are going to input ONE1 TWO2 and THRW3. So that is actually not the correct way of doing it, and you need to handle those errors. So what you do, you basically take the not argument, sorry, return values of the scanf function. Now yeah, this okay, I know that assignment has already informed me to not use any AI for solving the assignment or writing the code. But the point is that I use just like programming code completions to do the part of the assignment where I feel like, okay, I hopefully know this, and I need to basically check that, not check, basically, it just makes the life faster. Okay, I could actually go on and write all this stuff that, yeah, because it is not equal to 1, that means user has already input some random stuff. You have like input entered, sorry, entered some random stuff, and this is where the point is. I could do a return to the menu function. So because I think this is this I have installed, like not installed, initialized as void, so I don't even need a return. I could just basically do a menu call, okay, and it will be sorted. Okay, but there is one more thing. Generally it is recommended to clear the input, like input buffer, okay, and like clear the invalid input. So basically you do a empty character. Okay, I think there are better ways, like flushing it, okay, and all this, but this sometimes this actually works for small programs, so we are not going to bother more about this. So case 1 is solve BFS, case 2 is solve DFS, ID-DFS, and basically do the exiting program. All this main function is there. Now the point is, let's go back to the structure. Okay, now here, what do we have? We have the stdio.h, standard IO, that is input and output. We have the standard library. We have the string.h. Why do we have the string.h? To make the accents. Okay, just to name the accents, it's very simple, not too much. We define the capacities according to the problem, that is jug 1 having 3 liter capacity, jug 2 having 4 liter capacity, and the maximum number of states that we are going to basically traverse, or we are going to encounter in our particular queue, that would be 100 states. Now the point is, what is our target? The target is 2, having 2 liters in the 4 liter jug. Then what do we have? We have the structure of the state. So this is a state user defined data type. Now this user defined data type called state will actually have integers like x and y. It will have some parent index, and it will also have some action that is performed. Now these are states that are defined by some action. Okay, now the point is that you could actually have these actions mapped to some 1 2 3 4 and all this. Okay, let me just quickly check the recording here, so that you can do, or you can just simply have a character to it. Okay, this is a very simple way of doing it. There are better ways. Okay, and then what do we have? We are basically having the big old array to store every state that we discover. So we have a user defined data type states type of variable called all the states. Okay, these all states will store the, what do you call this, the current, not the current, all the possible states that we are going to encounter in this traversal. Okay, Then we have the int state count. So it counts the number of states we have already gone, or basically we are actually visiting all the states. Okay, this is a state count. Now, point is that why do we have this? We could actually later use it to get some performance analytics to that how many states I need to I already traversed, or what is the state count currently. It is the first level, second level, or third level. It could be used in multiple different ways based on the functions that you particularly develop for it. Now then we have the queue, because okay, I could have used linked list implementation, I could have used any other implementation, but I chose a array implementation because it is simple. You could just do it in what 5-6 lines. Okay, you create a struct, you create the items is the array. Okay, this is an integer type array, and this has the maximum capacity of 100. Okay, and then you have the front and the rear. So what is this front and the rear? These are particular integer variables which will coordinate with the position of the array that will behave as a queue. Now this array is like a queue. It is actually a queue which is there in front of a, let's say, cake shop or a bakery, because this is the example that I always like to give. And in that bakery, the first person who comes first will get the cake, and the person who's at the last will get it at the last. Okay, so that's why we have to do the initialization queue, NQ and DQ operations. So initializing is very simple. You basically increment the front to 0 and the rear to -1. Rear is the -1 means as soon as you do a single plus operation or increase the rear by 1, you means that your rear has started. That means your cake shop has opened. Now what do we have? Is the queue empty? The only condition where this is not the only condition, there are edge cases, but this is the most valid condition where if you are not using a circular queue, that if the queue rear is less than the queue front, that means your queue is basically empty. Okay, now like the first condition, initialization of the queue. Okay, so the rear is at -1 and the front is at 0. Next, what do we have? We have the NQ and the DQ operations where you add one more element. So in the particular parameters of the function, we are already taking the values, okay, that we need to NQ add to the queue, or in terms of the DQ operation, we are returning the value that is there at the front of the queue. So how do we do that? It's a very simple thing that we basically do a pre-increment of the rear index. Okay, and as we are like currently already incrementing it, so that means currently the first person has already come, so it should be not from -1, it has to be 0. So the 0th index, I have the value. Suppose the first person goes, then the next person comes, it will basically do a DQ operation in form of the front person who is there has to leave. Okay, so the queue returns the item, and it at the point that we are taking note of the front, it has increased from 1 to 2 or 0 to 1. After these simple operations are done, then we basically have to generate the next states. Okay, I think I will go to that particular function later, because that is the main thing, that is the brains. But first, you need to understand the flow of the program. So how the BFS solving algorithm actually works. So first we have the visited list, but this is I'm saying it list because Python people, mostly the people who will be watching are using Python, but this is actually a 2D array. In that 2D array, we are taking the visited, what do you call this? Visited to the array, we are taking the jug capacity +1 and the jug 2 capacity +1 for implementation of the map, that okay, this state has been visited, this state has been visited, and all this. Okay, why is it like that? Because understand that a visited state means what? It means that it could only have certain number of capacities for jug 1, which would be like 0, 1, 2, and 3. That means 0 liter, 1 liter, 2 liter, and 3 liter. It cannot have 5 liters or 10 liters, right? So initialize it at 0. Then we initialize the queue. After that, we basically start the algorithm where we have the all states. Now, what do you remember that how all states were actually defined? It was a state type variable, and this is a global variable. The implementation in form of a global variable is not actually a good programming practice, but for this small kind of problem, it is quite okay. Now, here what we are doing, we are having the all states as with a maximum number of states which are possible is 100. Now, let's go back to the algorithm. What we are doing, we are taking the we are actually typecasting it. So this is actually an array, and in that array, what do we have? It's a 1D array. Here we have the x value and the y value. See, I thank you for this VS Code, because in VS Code it makes it very easy to have the idea that this is an integer, this is integer, and all -1. But yeah, do you remember that it was x and then this was x and this was y, and then what was it? It was actually the parent node. So why is it initialized at -1? Because at the beginning you are like Adam and Eve, you don't have a parent, you probably have God, so it just it got initialized at -1. That means this is the parent node or the starting node. Parent node, if we are considering trees, let's just call it at the initial state. That's why we have the character array to take count of the action or the states. Okay, then we put all this information in form of a state, what do you call it, state variable, and we have done the typecasting and added it to the all the states. Okay, so all the states is again an array, and in that array it is an array of state variables. Okay, then in the visited we actually have this 0,0, which is the initial state, and this is marked as true. So this kind of state we have now visited. Now what do we have? We need to basically do the NQ operation, because that's in the previous video we showed that first you do the NQ so that your queue is not empty, and while we are checking for the queue is not empty, it will basically pass without any issues because your queue is actually not empty. Now after that we have the int, we take the DQ operation, means you pop out the element which is the current index, means you are at the 0,0 index. At that point what you do, you basically take the all states, and in the current index, which is the 0,0 index, you basically assign this to the current state. That will define the 0,0 as your current state. Now after that what we are doing, we are actually trying to check that did we win, means is it our goal state. Suppose it would, when the loop runs, it could be like 0,1, 1,2, 1,2 actually is the goal state, because 2 liters needs to be there in the 4-liter jug. Okay, so let me just quickly check the recording. It 0, yeah. Now after that, what do we have? We check the goal state. Did we win or not? So here in a later part of the function, we are going to create the function to print the path as well. If not, we are going to generate all the possible next moves. Now this is where this function is the main thing, because this actually governs the rules, or give me the rules are the order in which the actions need to be maintained or done. The actions could be pouring water, filling the jug. Okay, now filling the jug could be like I fill the 4-liter jug first, I fill the 3-liter jug first. In my algorithm, I have done the 3-liter first, then the 4-liter, then I have done the empty option, then finally I have implemented the pouring option. Okay, let's go and check how it actually has been implemented. So here are the parameters of it. Understand that what the parameters are. These are the generate next states. Okay, so what are the what are the parameters that it accepts? One is the current index. Well, the current index is basically your 0,0 state, or maybe your 1,1 state, or whatever be it, 3,4 state. After that, the visited. So visited list will need to be done, because see, your visited lumped list to the array will contain all the states that we are going to visit. Then what do we have? We have the queue. Okay, next what do we have? We actually have the we do a local variable initialization of the current position. And again I'm saying that this local variable initialization and everything is good here, but this all states, okay, this was initialized as a global variable. So suppose you don't want to actually have this as a global variable, then what do? You basically initialize it in the main function with the double pointer, so that you could use it from in that particular reference. But just making our life easier, let's just go with this. Okay, now you take the current state as the current, and then you remember that the state actually has x and y. X stands for the capacity, not capacity, sorry, the amount of water that is there in the 3-liter jug, and the y means the amount of water that is there in the 4-liter jug. Now when you do this assignment, you basically get the capacity of the 3-liter jug and the 4-liter jug. Now point is that, have we visited this particular state? So the state will be the jug capacity. Okay, this first rule, which is filling the 3-liter jug, means I do not care about what be the capacity of the 4-liter jug. My first point is I can fill the 3-liter jug to 3 liters. It will be a complete filling. There is no demarcation for 2 liter, 1 liter or anything. So after that, what do? We check that have we visited it. If we haven't, then only we are going to get into the loop. So what here we do, we basically mark this state as visited first. We first mark it as visited. Then we go to all the states and basically implement this operation where the jug 1 capacity, which is 3, is now assigned to the state. Okay. And why? Whatever be condition, I don't care. And whatever be the current index, the current index needs to change, but not particularly here. Okay. It will change later as we go along the program. Now then, we have the fill 3-liter jug. This is the action that we perform. Remember, in the state structure, we actually have this character which is called the action. So this is the action that we are performing here. So this is just an array to mark and print. That's it. Now then we do an enqueue of the current state while increasing the state count, because number of states now has increased from 0 to 1. After that, what do we have? We do the filling the 4-liter jug, and everything is the same. Just the y index here is the jug 2 capacity is 4 liters. Okay, if we have not visited the condition where it is whatever for the 3-liter, I don't care, but for the 4-liter jug, it has to be 4. And if we have not visited, then we are only going to go inside the loop, not even loop, the condition. And we are first going to mark it as we have visited. Then we basically do the assignment. And after doing the state assignment, we do the enqueue operation and increase the state count. After that, we empty it, which is similar, because now instead of the jug capacity here, instead of the jug capacity here, because we are emptying it, it has to be assigned to 0. Similarly, the 4-liter will be assigned to 0, like the y variable will be assigned to 0. And finally, in this particular thing, this is very important part of the whole program, which is the pouring operation, because you can't actually pour to a jug which is already filled, or you can't pour from a jug which is basically empty, right? So you need to first check what actually is there in the jugs. So you develop a pour variable, which basically amounts to the amount of water that needs to be poured. Okay, poured from or poured into. Now here you have the condition where x is less than, what is x? It's the amount of water that is there in the 3-liter jug. The jug 2 capacity is the total amount of capacity, and y is the amount of water that is not there. Let's say not there, the amount of water that is there in the jug 2. So when you actually minus this, say the jug 2 capacity is 4 liter and it contained 2 liters. Okay, and you subtract this, there is this 2 liters. Okay, 2 liters of empty space. Then what do you have? Is x is less than 2 liters. It has to be less than 2 liters, right, for it to actually be able to pour. Now after that, you must check it. Now the checking, this actually is a ternary operation. So a ternary operation is more like this. You have the variable assignment where you do the expression calculation or the evaluation, where expression 1 is and the expression 2. If these are true, then sorry, what I'm saying, this is the expression 1. Is this expression, if condition, else condition, whatever be it, some equal to some greater than equal to, or equality condition, whatever be the logical operation, you check if it is true or not. If it is true, then you go to the expression 2, which is the, like, you assign that value. Okay, will it be something 0 or 1 or anything? And then if it is false, then you go to the expression 3, and these are getting assigned to the variable. So that's how it actually goes. Now you know that this particular is the condition, and we are checking if this is true or false. So suppose it is, if we go back, suppose it is true, then what do? We do the assignment of the x liter into this pour variable. So then if it is false, then we just do the subtraction, which is jug 2 capacity minus y. So what is the jug 2 capacity? Jug 2 capacity, let's say, is in our condition is 4 liters. And let's say it contains just 2 liters of water or something, which is making this condition false. Suppose, yeah, say it is 4 liters, jug 2 is 4 liters, y maybe, let's say, 2 liters, and say x is 2 liters. Okay, so then it is making the condition false. So that's where you, okay, I'm getting one copy real quick. No way. Okay, let's continue. Now the point is, yeah, so what do we have? If it is, let's say, 2 liters or something like that, then you basically have to do assignment in this manner, which is the jug 2's capacity, which is 4 minus 2, that is 2 liters. Now the 2 liters is the amount of water that you are going to pour. Okay, that's it. Done. Now the point is, you are pouring from where to where? You are pouring from the 3 liter to the 4 liter. Okay. So because you are pouring from the 3 liter to the 4 liter, that means what? That means some amount of water will be reduced from the current content of the 3 liter jug, and some needs to be added to the 4 liter jug. That's why x minus 4 and the y plus 4. And this particular state you need to mark as visited. Then you repeat the same operation that you did before, and that's it. But the next point is pouring from the 4 liter to the 3 liter. Understand that this is basically the same, just the inverse of the variables. If the amount of water that is there in a 4 liter jug is less than the current capacity, or the actual capacity of the 3 liter jug, which is 3 minus the current volume, that is a liter of water that is there. So it may be something like 3 minus, suppose 2 liters are already there. So 2 liter is there. Then it is 1. So is the amount of water, that is y, in the 4 liter jug less than it? If it is less than it, then you, which is actually true. Say 1, so I was saying 3 minus 2, that is 1. And let's say it is 1. So it is false. Then what does it mean? The jug 1's capacity, which is 3 minus x was, I say that 2, right? So 1. So 1 liter needs to be poured from 4 liter jug to the 3 liter jug. And basically in that sense, you do check the state variable, because you are pouring from the 4 liter, it has to be x plus the pour, and it has to be y minus the pour, because from x you are pouring into the 3 liter one, and you're pouring from the 4 liter one. So that's it. That's kind of ends it. And let's actually run it real quick to check the output of the which, let's see, I need to go to CS4, then assignment, then I do a DCC. Okay, hopefully no errors, which is good. BFS, then because only one option is valid, so yeah, so it was adding it. So this is doing the BFS from 0 to 0. It pours to 3 liter, then it pours to the 4 liter. So these are the 2 states. These are new 2 states which are possible. Now then what do? We are starting processing from the state varies from the 3 liter. Okay, so these are the two BFS searches, and then 3, 0 is possible. Now then we are generating the new states 3, 4 and 0, 3. Then we are adding it to the queue. Then we are processing from the queue again, which is the next state, which is 0, 4. Okay, because it was the first thing that got inside. So we are processing from the state 0, 4. Then we do 3, 1, basically, because now we are doing the pour operations. Okay, and we are sorry. Yeah, so yeah, after that we discover this new state, which is 3, 1. Then we are processing from the 3, 4 state, because after this it should be, yes, this is the thing that got added to the queue, which is 3, 4. Now we are processing from from the queue, that is 3, 4. Yes, after that we are processing from the state 0, 3. Then we discover a new state, that is 3, 3. Then we basically we continue the action, and don't mind this particular thing. We are checking the adding to the queue. Okay, then what do? We basically do again the pouring, and then okay, I think this zoom in is making it difficult a little bit. Let me just do something like this. Yes, this is better, I think. Okay, now where we were generating the new states. Okay, I think 3, 4, it was clear, right? Processing the state from the 3, 4. Okay, after that what do? We again generate the new states. Were there any generation possible? Currently no. Then we go to the next state which was possible, which is, yes, after 3, 4 it was 0, 3. I'm at this point I should have added some lines, because it's difficult to read. I'm missing out which line I'm from where. So after that what do? 3, 3 here. Okay, then we discover the new state. Okay, you can actually fill up the 3 liter jug, so you get it 3, 3. Then you go to the next state processing, which is 3, 1, which is from this one, which got added to the queue. Then from 3, 1, you go to the new state possible. You discover a new state. It got added to the queue. Then you go from the state 3, 3. That means it was somewhere here. Yeah, 3 comma 3. So you process from there and you discover a new state, which is 2 comma 4. Means your port from 3 liter to the 4 liter. Then you this 2 comma 4, you then go from the 0 comma 1. So this is the next state that got added. So from here you are processing. From there you discover another new state, which is 1 comma 0. Basically you pour it from 4 liter to the 3 liter, and after that you are processing from the 2 comma 4. 2 comma 4, that means this one. Yes, this one. And then you discover a new state, which is 2 comma 0. Basically you dump this. Okay, empty this. Then after that you're processing from the state 1 comma 0, and then again you discover a new state, which is 1 comma 4, which got added. Then you're processing from 2 comma 0. So this is the 2 comma 0. Just notice that it is just 2 lines before always. Okay, and after that you basically discover a new state, which is 0 comma 2. And do you know what it actually means, which is our state? Now you are processing from 1 comma 4, and suddenly you just discover the new state, which is 3 comma 2 as well. But remember, we have already got the solution as 0 comma 2, which is the goal state. This is the implementation of BFS algorithm, done as quickly as we can, and hopefully I will be able to upload the other videos. So goodbye.